Hello, today we'll look at solving systems of equations algebraically. Recall that when we are looking for systems of equations, the solution for system of equations, we're looking for that solution. So we're looking for that point of intersection. But to be clear, there are three different types of solutions for our systems of equations. So we can either have one solution where they intersect at one point and is considered a consistent independent system. We can have no solution where the lines are parallel, so they never touch each other, they never meet, they're inconsistent. Or we can have infinite many solutions where they are the exact same line. They lie right on top of each other, and that's known as a consistent dependent system. All right, so there are three ways to solve systems of equations. We can use substitution, elimination, and graphing. Substitution and elimination are considered algebraic ways because we just use our algebra, and graphing I have done in a separate video on its own. So this says solve this system by substitution. However, whenever you see solve it a certain way, unless you are required to submit your work, solve it the way that is best for you. Okay, solve it the way that's most convenient for you. Now, for this purpose, it is easier to use substitution. And the reason it's easier to use substitution is because this is equal to y and this is equal to y. So that means if this is equal to y and this one is equal to y, then they're equal to each other. So the two equations are equal to each other. So I'm taking, all of this equation and I'm plugging it in for this y value here. So I get x minus 3 equals 4x minus 9. And now I can solve it. So the first thing that I want to do when I solve an equation is I want to get all my variables on one side. So I'm going to subtract 4x on both sides. That goes away and I get negative 3x minus 3 is equal to negative 9. Then I'm going to move this 3 over because I want my x by itself. And I get negative 3x equals negative 6. Last, I'm going to divide by 3 on both sides. And I get x is equal to 2. Now, this is unfinished, correct? Why is it unfinished? It's unfinished is because I'm looking for a point. A coordinate point has two values. It has an x value and it has a y value. So I need to take this value of x and plug it back into one of these equations. Does it matter which one I choose? Absolutely not. I will get the exact same answer no matter which one I choose. So I'm going to choose the bottom and I get y equals, instead of that x, I'm going to put 2 minus 3. So y is equal to negative 1. So now I have my solution. My solution is at 2, negative 1. Let's plug it into the other one just to verify that I get the exact same answer. So I get y equals 4 times 2 minus 9, which is 8 minus 9, which is negative 1. So we know that that's going to happen because it is that place where they intersect. It's the place where they're both equal to each other. The next one, it says to solve by substitution. I can't the way it is because it's not in a form of x is equal to something or y is equal to something. Remember, you do not have to follow that, but for this purpose, I will. So I'm going to add this y to the other side, and I have x equals y plus 13. So now I can take everything that I have here and I can plug it in for my x values. My x value is right here. So that's going to be 4 times all of this, y plus 13, plus 2y equals 10. So I get 4y plus 52, just distributing it through, right? Just solving the equation, equals 10. Combine my like terms, so I get 6y plus 52 equals 10. Then I'm going to subtract 52 from both sides. And I bring everything down. I get 6y is equal to negative 42. Divide both sides by 6. And I'm going to have to come up here and apologize. So y is equal to negative 7. Am I done? I am not done. I need to find out what x is. Which one am I going to plug it in? I'm going to plug it into the easiest one, which is this one right here. That's going to tell me exactly what y is. So I have, let me change the color because I get x is equal to negative 7 plus 13. So x equals 6. So my point where they are equal is at 6, negative 7. So now I can go back and I can check my answers. I can check my answers to see that I'm correct because I have a tool that can help me do that. So I have my free graphing calculator that I'm using at Desmos.com. All you have to do is put in Desmos.com and you can use this graphing calculator too. And so I'm going to put in my equations that I have. So that's y equals 4x minus 9. There's my first line. And y equals x minus 3. There's my second. And the intersection point was at 2, negative 1. Let's see, was that our solution? It was at 2, negative 1. So I just verified my solution here. Let's verify the second one. So I'm going to exit those out. I'm going to have y equals, actually it was not y equals, it was 4x plus 2y equals 10. And x minus y equals 13, I believe. Okay, I'm just going to scroll down here, click on my solution, and it says 6, negative 7. Let's see. 6, negative 7. So I just verified my solution, and that was the substitution method. The next method is the elimination method. And the elimination method basically means that I want to eliminate one of my variables. One of my variables has to go. And so I want to decide which variable should go based on multiples. So looking at problem 15, I have 8x minus 6y equals negative 20 and negative 16x plus 7y equals 30. Well, looking at my x values, I can easily see that they have something in common, right? So if I multiply this by 2, that gives me 16. And that means my x value can go away. Also, I want to make sure that they have opposite signs. So this is positive, this is negative. It works out. So I'm going to multiply this whole top thing, it has to be everything, by 2. So that's going to give me 16x minus 12y equals negative 40. So now my x value has been eliminated. And I can add these. So 7y minus 12y gives me negative 5y equals 30 minus 40 gives me negative 10. So y, oh, sorry, divide by negative 5. I apologize. Going a little too fast. So y is equal to 2. So now I can take this 2, because I have to find my x value also, and plug it into either one of these equations and find out what my x value is equal to. So I'm going to plug it into the first one. So it's going to be 8x minus 6 times 2 equals negative 20. And that gives me 8x minus 12 equals negative 20. So I'm going to add 12 to both sides. And that gives me 8x equals negative 8. Divide both sides by 8, and I get x is equal to negative 1. So my solution for this one is negative 1, 2. Remember, my x value always goes first. All right, let's do the second one. Again, I can choose any variable to eliminate. I always want to look at my multiples. Here I have 6 and negative 1, and here I have negative 12 and negative 6. This one is already in opposite form. This one, they do have something in common. They both have the 6 in common, but and one is positive. Both of them are negative. So I'm going to do this, eliminate the x value instead, and I'm going to multiply everything at the bottom times 6. Does it matter which one I eliminate? Absolutely not. You're going to get the exact same answer, I promise. So I'm going to put it up here. So I get negative 6x minus 36y is equal to 24. So now my x's are going to cancel out. So that's 36 plus 12, or negative 36 minus 12, which gives me negative 48y. And 24 plus 24 is 48. So divide both sides by negative 48. My y is equal to negative 1. Now I need to go back and find my x. So I'm going to choose the bottom one. Now I could plug it in the top one that I manipulated, or the one that was originally there. I'm going to use the one that was originally there. Doesn't matter which one. I'm going to get the same exact answer for both, but this one looks like it's easier to manipulate. So I'm going to choose that one. So that's negative x minus 6 times negative 1 equals 4. So that's negative x minus minus is going to be plus 6 equals 4. Subtract 6 from both sides. So I get negative x is equal to negative 2. Divide both sides by negative 1, and I get x is equal to 2. So my solution is 2, negative 1. All right, let's check it on our calculator. All right, the first one was 8x minus 6y equals negative 20. And then I have negative 16x plus 7y equals 30. I'm just going to move my mouse till I get to the solution point. And it's there at negative 1, 2. I remember that one. Let's do the next one. It was 6x minus 12y equals 24. And negative x minus 6y equals 4. And that solution is at 2, negative 1. And that's what we had, 2, negative 1. All right, last one. I chose this one because it had fractions in it. And most people, when they see fractions, they get really, really afraid. So let's get rid of those fractions. So the way that I get rid of that fraction is I need to multiply by the least common denominator, or the least common multiple of my denominators. And my denominators are 9 and 18. So the least common multiple of 9 and 18 is in fact 18. So I'm going to multiply everything right here by 18. So 18 times 1 is 18. Plus 18 times 5 over 9y is 10y. And 18 times negative 7 over 18x is negative 7x. All right. So now I'm just bringing this on down. So it is all over the place, right? I have my x here, my x on this side here, my y on this side here, my y on this side here, my constant terms over here. Let's go ahead and make it where it looks a lot neater, where everything is together. So I'm going to move this y to the opposite side. So it's going to be the opposite sign as well. So that's going to give me a negative 7x minus 10y. And it's all still equal to 18. The same thing here. I'm going to move that x over here, so it's positive, it's negative here, so it's going to be positive over on the other side. So it's 8x plus 12y equals negative 24. So now I can choose my I can choose which one I want to eliminate. And I am going to eliminate my y value. Does it matter which one I choose to eliminate? Absolutely not. And actually, I have run out of time. I can see my time ticking away. So you know what I'm going to do? I'm going to put it in my calculator instead. So let's do that. So I put it in my calculator, fractions and all, and it showed me that it intersected here at this point, 0.22, negative 2.147. That was a fraction. But I encourage you since I've already done it for you, go ahead and try to solve it using the elimination method and let me know what you